Hey guys, so we are going to talk about sequences again, just like we talked about yesterday in our teacher group. So what we need to think about is that sequences, remember, means the order that something happens. So notice my position number is always 1, 2, 3, 4, but I want to come up with a rule of how to get from n over to my value. So I don't want to know how to get down from my values. I want to know how to get from 1 over to 2, from 2 over to 5, so on and so forth. So, if you recall from yesterday, we talked about the fact that you can find out what you're jumping by, but that's not going to mean that you're jumping by that to get there. So, what do I do to 2 to get to 5? Well, to get from 2 to 5, I'm going to do plus 3. What do I do to 5 to get to 8? I'm also going to do plus 3. So notice that I'm going up by 3 each time over here because I'm going up by 1 each time here. So I can go ahead and fill in my question mark if you want to. We know that since this is just going up by 1, 2, that 8 plus 3 will get me my question mark. That means I'm thinking that my question mark is going to be 8 plus 3 is 11. So I could fill in, I think this is going to be 11, but we're going to check that using the rule that we come up with. So remember, we said that we're doing plus 3, plus 3, plus 3. Well, instead of adding 3 each time and then having to write out every single position number, the easier way, instead of just adding over and over and over, so if I say plus 3, plus 3, plus 3, instead of adding 3 times, it's easier to multiply times 3. So if we're adding 3 to get down from our positions, we know our rule to get from n is going to say 3 times n. If we're adding 3 to get down our positions, that means our rule is going to say we're going to take n and do 3 groups of that. So this is saying to get from 1 over to 2, we are going to multiply 3 times 1. Well, 3 times 1 would get us 3. So what do we have to do to 3 to get down to 2? Take away 1. So that means we want our rule to say 3n minus 1. So let's try it out for 2. If we were saying 3n minus 1 and we were plugging in 2, that means we'd say 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. And that is what we wanted to get out. So that worked for this one. Let's try it for this one. 3 times 3 minus 1. 3 times 3 is 9. 9 minus 1 is 8. And that's what we wanted to get out. So let's try it for 4. 3 times 4 is 12. 12 minus 1 is 11. So our rule here is going to be 3n minus 1. That's how we get from the position to the value. Our question mark we filled in was 11. Perfect. Just like what we talked about yesterday. What if instead they just gave you a list of numbers and they told you this is the sequence that we are following? So we're following a sequence that says 1, 7, 13, 19. Well, remember, anytime we're talking about sequence, it means the order it is happening in. That's what we talked about in class yesterday. That's what's true. So anytime you have a sequence, you're always going to plug in. You don't have a table right now, but we can turn this into a table. So all we have to do is take our n value and our y value. We always write this in your notes, always plug in 1, 2, 3, and 4 for n, because n is representing the position number, so it always goes in order 1, 2, 3, 4. So we're going to plug in here for n 1, 2, 3, 4, for y 1, 7, 13, 19, because these are our values that match these. So we would think, how do I get from 1 to 1? Well, just times 1. That didn't work though. So we're going up by 6. That means to get from n over here, we're going to do 6 times n. Well, if I do 6 times 1, that's 6. So I have to take away 5 to get 1. 6 times 2 is 12. 12 minus 5 is 7. 6 times 3 is 18. 18 minus 5 is 13. 6 times 4 is 24. 24 minus 5 is 19. So our rule for this would be 6n minus 5, and you could find the 100th term if you wanted to.